Hey guys, Erik here. I was supposed to show you guys what I got in the mail yesterday, all my Wicked Edge stuff while I was setting it up, but I got a little excited this morning and just set it up by myself. So, just show you what I got. I got the new arms, the nice pivot. Haven't tried it yet. With the riser, comes with a new thingamabobber. It's quite a bit bigger, the new one's quite a bit bigger. It seems like it's more accurate, and I'm hoping these will actually hold and stay where they're supposed to. But yeah, I'm really excited to give these a shot, so I will see how it goes. And one more thing. A lot of people are wondering how I set these up on the Wicked Edge, so I can get them sharp, and I think quite a few of you actually have a Wicked Edge, so you would like to be able to sharpen it yourselves. So let me just show you here. I usually just set them, on the top holes here with this, and I put it at about B1/2. But the tricky part, too much coffee, my hands are shaking here. Let's see, the tricky part is I raise it up just a hair, just so I can get that front bevel all the way. So it's not very scientific, and I wish I could be better at, give you a better idea of how big of a gap that is. Yeah. So any more questions, feel free to ask. Oh, and by the way, I also got the new to me, 50 and 80 grit stones, which should cut down my sharpening time a lot because I won't be trying to find the edge with the 100 grit stones, which I have thoroughly worn down on the edges here. So I got a new set of those as well, to just replace the old ones that I have knackered. So yeah. Alright, so I was just gonna start doing this again by myself, but I started with these 50 grit stones. And what I've been doing in the past when I start is I use the 100 grit stones, and I just try to get the edge, because we machine it down to a point, but I still have to work for a while to get it down to a sharp point. So it's been taking me way too long, like 10 to 15 minutes just to find the edge, which is kind of ridiculous. So I got these 50 grit stones to try to eliminate a lot of that time, and I think they will do the trick, because just doing a few passes, it's eating away the metal. You might be able to hear this. It's just quite a bit rougher. It's awesome. So yeah, I just wanted to mention that, and I will keep running through the 50-80 grit stuff. And I would film myself, but I'd rather turn the music up and rock out while I do this, so see you later.
One aspect of the knives that I don't think I've gone over yet is during the final assembly, these parts are fully machined, they just have to be paired together, put the blade in, get it all set up, and there's a lot of little things that I have to go back and do because I machined them wrong, or just slightly a little bit off. So on every single pair of handles I've got to go back and change this. One of the things is this pocket right in here, where my version of the Hinderer lock bar stabilizer will go. Very difficult part to make, very difficult hole to make. That hole inside is threaded and it goes almost all the way through. So, you know, you got to go deep enough without threading through, and it's just a real pain, but it's worth it because it's pretty awesome. But if you see, you can see that hole goes all the way over to this side, past the gap, through that little bit. That little bit needs to be bigger, and I'll show you why once I get this together. So that's in. You can see it's a really tight fit, and if you listen, if you can hear it, the round disc is actually rubbing against this side of the handle, because I don't think I planned for clearance. I just made it a total circle. So to fix this little area of the handle right here, I've got a Dremel with just a 1/16 inch stub end mill, 4-flute end mill. I use tons of these for cutting out the lock bar slot. This one was kind of beat up and chipped or whatever, so I just put it in the Dremel. And all I'm going to do is basically relieve that area by hand. And then next time for CNC, I'll chop it out and make sure there's enough clearance. Ta-da! Now it'll clear. The other thing that didn't get done properly on every handle was actually threading this hole. I use a fancy expensive thread mill to helically interpolate the threads. It's not a tap or anything. It uses CNC to actually cut those threads. And for some reason I must have had an offset wrong, because like half of them, no, not even, like probably 30% of them work perfectly first try. But most of them, the threads just aren't deep enough. So I must have had an offset wrong when I made all the handles. So to do that, I've just got 2 high-speed steel taps. They were sort of bottoming taps. You can see the one on the left, I just shortened. I just ground it down so it's totally flat. So I just chuck it up in my drill. And I've already done these ones. But I just set the drill key, the chuck really, really low. I'll even go lower just for demonstration purposes. And there's a perfect example of what happens on some of them. So that drilled all the way through, because you can see how thin that piece is. That's the amount of leftover that I'm dealing with here. It's probably like 5/1000ths of an inch. I think I planned it to be about 8, but anyway, because I'm having to tap it like this, sometimes it just gets screwed up, and I just have to go through it and, and live with it being all the way through. Oh well. My personal knife, the wood one, goes all the way through, and it's kind of cool because you can see the color of the lock bar stabilizer through it, but it's not exactly as I want it to be. I want it to be like that, where you can't see it. It's a hidden gem. I want you to not be able to figure out how I do this stuff, because it's cooler that way. Like how on the clip, the screws are hidden on the back side. But whatever, if it goes through on some of them, it's no big deal. Nobody's going to care. It's just not ideal. So now, of course, there's this huge giant burr right there. And to get that off, put these taps away. And I use a countersink. And I just kind of do that by hand. Real slow. Put some pressure on it, check it. That's probably good. I'm going to go a hair more. There. So that's one of the things that I have to do on every single handle, is to make sure those threads are perfect so that the screw goes all the way in. Another thing that I do is I also take this countersink and I put a little chamfer. These are where my spacers go. this through hole right above my thumb, and this through hole right above my thumb. I put a chamfer on those so that the spacer sits perfectly flush with the handle, because otherwise sometimes it doesn't. So a little detail, not really important. Another thing that knife maker Todd Begg told me at one of the shows was to ream your handles, the spacer holes, ream them together. Now all you guys making knives by hand, this is very obvious to you because this is how you do it. You know, you often cut out your stuff and then you clamp them together and then drill your holes at the same time. Drill them together, ream them together, keep your handles clamped, profile them together, you know, on the grinder, and then they match perfectly. With CNC, you kind of want to trust the machine that it's going to put a hole there and a hole there exactly where you tell it to. But when we're talking for overkill here, Todd said even with CNC, you want to make sure that some of your holes are paired together. So I put a pivot hole through the pivot, and I put a hole through my lanyard tube, so that now these handles, they're perfectly in relation to each other, they're not moving. And then I take 1/8 inch reamer, doesn't have to be carbide or anything, and I just ream these together. These might have already been done. But that just ensures that the spacers are now perfectly accurate so that they keep the two handles perfectly together. Yeah, so there's lots of little things that I have to go back and do. That for the next time, I've got a huge long list of junk to change for the next time so that this doesn't happen. And I can just, this whole process will be quicker for every knife. Quicker is better, more knives out the door. Another step that I do for every single blade is under this magic towel is a demagnetizer. So I'll go through it first and then I'll show you the thing. But it's a switch, you can see the stuff jumping. Anyway, it creates a magnetic field that removes any magnetism left in the blade. Now these are stainless blades, but because they're so high carbon, they are quite magnetic as well. And working with them and, you know, sanding them and sharpening them, it just makes them magnetic. So a couple passes there, and now it is completely free of magnetism. And in a, you know, shop, there's dust everywhere, especially steel dust. So when these are magnetic, you know, you get lots of burrs and little junky stuff stuck to it all the time. So a demagnetizer is worth every one of the $42 or whatever they cost. A very simple device. It's basically a transformer, and it does something across the two halves of the transformer. I forget. I looked into it once, but it's pretty cool how they work. And you can kind of feel the pull as you cross the center line. Anyway, they are absolutely required for working with this kind of stuff, because you don't want all that metal dust stuck to it. And you want to make pretty knives, pretty whatever you're making. There you go. Alright, here's something that's been driving me nuts the past few minutes. These are my Lefty knives, and I'm putting them together, and the Lefties in and of themselves were an absolute pain to make because everything is flipped and completely opposite. It's a true Lefty, you know, so the lock bar and everything is on the left hand side, and the thumb stud and everything. Now, while that may seem like it's easy to do with CNC, you just reverse everything. I basically had to rewrite everything, recode everything, design all the parts as Lefty parts, and it's like all the work over again. From the start. So it was actually a real pain in the butt to do, but now that I've done it, I can make lots of them. Except I screwed something up on them. And I'm humble enough to tell you guys about this, but here is this is the stop pin. This is what makes the blade stop in the closed position. like that. See that pin right there? And then in the open position, that pin also stops it in the open position. Now it's just a little dowel pin, which I can't seem to get out right now. But little stainless steel dowel pin. This is the only thing on the entire knife that is not modified or made from scratch. Everything else is either made completely from scratch or modified from its original form. So I thought that was kind of cool. But drop my bearing. Okay, bearing goes in there. Now something in these lefties is inaccurate because, if I can get this to not glare, the stop pin should be centered in that arc. You can see right now it's rubbing on the top side and I can feel it. It's stuck right there almost. And then if I go down here, maybe I'll get some light, there we go. And now it's got clearance. So on this side it's smooth, it mates up with this closed position perfectly, more or less perfectly. But so it's smooth, smooth, smooth. Right here it starts to get sticky because it's rubbing, and it rubs here. And then in the open position, it's hard because there's so many shadows. There we go. There's an accurate representation. So you can see it's not perfect, it's not aligned. Something is a little bit off, like 0.005 of an inch off or something, maybe 10. So I'm going to have to go back through my design, through my code, and figure out if it's the arc, if it's the pivot hole, if it's the handle pivot, the handle stop pin hole, you know, all those things. It could be any one of them, I'm not sure yet. But I've just got 2 lefties left in this batch, so I'm just going to take my Dremel and clearance the blade so that it's got room and doesn't scratch and all that stuff. So that's what I'm up to right now, and it's kind of annoying, but all 5 lefties that I made were exactly like that, so it was definitely a problem with the code, and I will fix it for next time.